In the shadows of history, two great minds shared an obsession. Pythagoras, the ancient Greek mathematician, and Nikola Tesla, the pioneering inventor. Their fascination with triangles held the key to their mysterious connection. Pythagoras in ancient Greece was entranced by the mystical properties of the right-angled triangle. He believed it held the secrets of the universe. That numbers were the very essence of existence. He spent his days and nights exploring the mathematical intricacies of triangles, unraveling their hidden powers. Legend has it that he discovered the Pythagorean theorem, a revelation that reshaped mathematics and science. Centuries later, in a laboratory filled with humming machines and sparking coils, Nikola Tesla found himself equally captivated. His obsession lay with equilateral triangles, whose symmetry and balance he believed held the key to tapping into the Earth's natural energy. Tesla's experiments with the power of three led him to envision a world interconnected by wireless electricity, a concept way ahead of his time. In the midst of history swirling around them, Pythagoras and Tesla's lives never intersected. Yet, their shared obsession with triangles bridged the gap between ancient Greece and the modern era. The triangle, a symbol of their shared passion, transcended time and space, reminding us that the pursuit of knowledge and the mysteries of the universe can unite even the most distant souls. In the end, the triangles they cherished represented not only geometric perfection, but also the power of human imagination. Pythagoras and Tesla, separated by centuries, left a legacy that continues to inspire and intrigue, their obsessions forever enigmatic and intertwined. In this video, we will look at everything triangle. So, what is a triangle? To kickstart our lesson, we will look at some keywords to define. From the name, tri suggests that there's three, and angle, well, the word speaks for itself. So it must mean that a triangle is a shape with three sides, or with three angles, right? And hence three sides. Not all triangles are made equal though. We have different types of triangles based on the sizes of their angles and also the lengths of their sides. So we shall look at them one by one. We are going to look at the general properties of triangles, and then we will look at the specific properties of specific triangles. In general, a triangle is a shape with three sides and three angles. You can see in our diagram, we have a three-sided shape which automatically has three interior or internal angles. The internal angles of the triangle add up to 180 degrees. So that's an important relationship to know. It will be very important in manipulating other relationships concerning triangles, which we shall look at in other videos. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. In our triangle there, you can see that this exterior angle labeled E is equal to the two opposite interior angles labeled A and B. So that's an important relationship which will be also useful in other geometrical studies. The easiest triangle to remember is the equilateral triangle. The word equi means it's equal, lateral means side. So this triangle or this three-sided shape, which we also call a polygon. So this three-sided polygon or three-sided shape has got three equal sides. This triangle is an important one. This is the triangle that Nikola Tesla first about. His work was mainly focused on the equilateral triangle and its properties and how it held secrets to the universe. An isosceles triangle has two equal sides, and hence the angles falling between these two sides and the different sides are also equal. Maybe mathematicians looked for a funny way to describe a wizard's hat and called it an isosceles triangle. Who knows? The next triangle that we'll look at is called a scalene triangle. This triangle has no equal sides and no equal angles. All the sides are of different lengths. We have different types of scalene triangles. We have three categories which we can classify these scalene triangles. We have an acute angled scalene triangle, an obtuse angled scalene triangle, and a right angled scalene triangle. We shall look at them in detail in a moment. So we'll start with the acute angled scalene triangle. The acute angled scalene triangle is a triangle where each angle of the triangle is less than 90 degrees. That is, all the interior angles of the triangle are acute angles. The next one is the obtuse angled triangle or the obtuse angled scalene triangle, where one of the angles is more than 90 degrees. You can see here in our example that the obtuse angle is 96 degrees and the other two are 37 and 47 degrees respectively. In order to draw this triangle, you need at least two sides and one obtuse angle so that you may be able to come up with this one. We move on to the third type of scalene triangle, which is called the right angled scalene triangle. This one has got one of the angles being equal to 90 degrees or a right angle. This is the triangle which fascinated Pythagoras so much that he ended up coming with a Pythagorean equation. Again, if we follow in our other video, we'll look at the Pythagorean triples and how the Pythagoras theorem came about and how it is used in geometry and in other various walks of life and in mathematics. So you can see here that one of the angles is 90 degrees and the other two, one of them is 60 degrees and the other is 30 degrees. Now, here are some basic calculations which we may have in order to manipulate the triangle. In order to find the area of a triangle, it is very simple. We are going to multiply the base labeled B and multiply by the height labeled H. That is those are some of the key dimensions. Let's say we have a triangle labeled A, B, and C, where B is the base, A is one side, C is the other side, and H is the height. Take note that this H is the perpendicular height, which means the line H or the height H has to form a 90-degree angle with the base. Alright? So when the base is given and the height is given, you can be able to calculate the area of a triangle and give the units as square units. So in this triangle, B refers to base of the triangle, H refers to the height of the triangle. Right. Now, in order to calculate the area, you are going to say, we're going to multiply the base times the height, then you divide by 2. We are going to give proof of this in another video, but for the purposes of this video, it is important to know that the area of a triangle is found by multiplying the base and the height and dividing the answer by 2. So for any kind of triangle, you can use this formula because for a right angled triangle, it is very simple. The height is already given. For a scalene triangle, you need to calculate. For a scalene triangle, you just need to look at the perpendicular height considering the base, and then multiply that by the base and divide by 2. And then you find your area in square units. To calculate the perimeter of a triangle is very simple. Just add all the 3 sides together and give the answer in the required units. So let's try a few problems, shall we? The first problem is asking you to separate the 2 triangles and identify the scalene. It is very easy in this picture because you already have a triangle with a 90-degree angle. So you just need to check whether the other 2 sides are equal or not. If they are not equal, then you have your right angled scalene triangle. The second question, which triangle is the isosceles triangle? It is very simple because as an isosceles triangle has 2 sides which are equal and then 2 angles which are equal as well. You can see that it is the one which you've selected. Hope you have benefited some from this video. If you enjoyed this video, please like, share, comment, and subscribe for more. Thank you. Meet you in the next video.